So in this video we will be discussing the locus of a circle. So let's just start by doing an equation of a circle with Cartesian form. So let's just say we have a circle with center, go 1, 5. So we've got center with circle 1, 5. Circle with center 1, 5. And radius of 3. Alright, cool. So let's see how it would represent this in Cartesian form. So in Cartesian form, this would be x minus 1 squared, as all the signs are backwards, plus y minus 5 squared equals the radius squared. So that would be 3 squared equals 9. So that's the circle in Cartesian form. Which then on a graph would probably be somewhere way up here. Let's say 5 is around there. Center 1, 5. So it'll probably look a little something like this. I mean, it should be a little bit further out this way, but that's fine. So it's a circle with center 1, 5, radius of 3. So how would you represent this on the eigenplane or the complex plane using with a locus? So this here is obviously on the Cartesian plane. So what we can do, again, is use a modulus. So we'll go over here. So let's just define this point here, the center, as z1. And z1 is equal to 1 plus 5i. Z1 is equal to 1 plus 5i. And let's just say our locus is equal to z. Okay. So what we can do is take this, and what we'll do is you do the modulus of z minus z1. So that just means our locus minus the distance between our locus and z1 is always equal to a certain distance. So the distance between our locus and z1 is always equal to a certain distance, and that distance can be 3. Cool. So what this might look like on a graph would be, well, it's a little bit wonky, but no matter. So we've got z1 at 1 plus 5i, so somewhere up here. And our locus is just got to be 3 away from it. So it could be here. Could be there, 3 away, around there. Could be 3 away up here. All the way around, and you'll see that forms a nice, neat circle. That one's also a little bit wonky, but the distance between z and z1 has always got to be 3. Oh, I don't know what I've done there. Oh, gone too far in. There, z and z1 has always got to be 3. So that's how that works. And now, if we were just given this, say we were given z, we're given for a new one, we're given z1 equals 3 plus 2i. And we were told that the distance between z and z1 was equal to 2. How would we know how to graph this? And how would we be able to accurately graph this using something like a class pattern? What we can do is let z equal to x plus yi. Z equal to x plus yi. We're just going to move over here so we've got a bit more space. Let z equal to x plus y. So now what we do is we just sub in all these values. So z equals x plus yi. X, oh, it's a bit wonky, but all good. X plus yi minus c1, so we'll put it in brackets. 3 plus 2i I, and that all equals 2. Set that bracket there. Alright, so now what we can do is we can group the real and imaginary terms. So we got x minus 3 plus I outside of y minus 2. And that distance equals 2. So now what we do is we'll expand this. So what we'll have here, this is equal to the square root of x minus 3 squared plus y minus 2 squared, and the I disappears because it's only there to denote that this is the imaginary term, equals 2. So now what we can do is we can square both sides. So what that will do, it will just get rid of the square root here and make this into 4. So we now have x minus 3 squared plus y minus 2 squared equal 4. Cool. And then we can, and what you'll notice this looks like is also the equation of a circle. So this we can see it's a circle with center 3, 2, and radius squared. So radius squared, so we take the square root of that. Center, the radius of 2. Hang on, radius of 2. So that is how you can get the locus of a circle using complex numbers. Yeah. So what you could see from this, I'll just draw out what this would look like just for some closure here. If I draw out a plane, so this is the Argand plane. So imaginary there. What have we done? Imaginary and real. And points at 3, 2, so somewhere around here. Radius of 2. So we can draw that should touch the x-axis. And draw a nice, somewhat neat circle in here. And what you can see, this fulfills our locus's restrictions, as the locus is this circle here, the circumference of the circle, and it's always equal to a distance of 2 from z1, which is at 3 plus 2i, with a distance of 2. So that is how you do a locus of a circle using complex numbers.